Mariana Trench exploration. The Mariana Trench represents Earth's final frontier right here on our own planet. Most people assume this deepest part of our ocean sits largely unexplored, like an alien world waiting for discovery. After all, we've sent more people to space than to the bottom of the Mariana Trench. But what has actually happened with deep-sea exploration in recent years? The 2025 expedition data reveals something that completely changes this perception. Advanced remotely operated vehicles and autonomous underwater systems have conducted dozens of successful missions to the trench's deepest regions. These sophisticated machines can withstand pressures exceeding 1,000 times greater than at sea level. High-resolution bathymetric mapping has created detailed three-dimensional models of the trench's complex topography. Scientists have discovered hydrothermal vents, unique geological formations, and thriving ecosystems of specialized organisms that survive in complete darkness. New sensor technologies capture unprecedented footage of creatures living in conditions once thought impossible for life. International collaborations bring together researchers from multiple countries, sharing resources and expertise to tackle these extreme exploration challenges. Modern materials engineering enables equipment to operate at depths exceeding 36,000 feet below sea level. Deep ocean exploration advances rapidly through technological innovation, but some natural phenomena on our planet's surface follow patterns that completely contradict popular wisdom. Lightning strike patterns. Lightning never strikes the same place twice. This old saying gets repeated so often that most people accept it as scientific fact. The phrase suggests that lightning somehow remembers where it hit before and actively avoids those locations. But what happens when you actually examine real lightning strike data? The 2025 meteorological data reveals a completely different story. Advanced lightning detection networks track millions of strikes annually, creating detailed maps of where lightning hits most frequently. These systems use electromagnetic sensors and satellite monitoring to record precise strike locations with unprecedented accuracy. Some places get hammered by lightning repeatedly throughout the year. The Empire State Building takes an average of 25 lightning strikes annually. Radio towers, cell phone antennas, and skyscrapers experience multiple strikes during single storms. Mountain peaks in regions like Colorado and Montana get struck dozens of times each summer. Geographical features create natural lightning magnets that attract strikes predictably. Elevated terrain provides the shortest path between storm clouds and ground. Metallic structures conduct electricity efficiently, making them prime targets. Areas with high humidity and frequent thunderstorms generate the atmospheric conditions necessary for repeated lightning activity. Certain locations experience lightning strikes so frequently that meteorologists can predict seasonal patterns with remarkable accuracy. But predictable patterns aren't limited to weather phenomena. They extend to how we measure and understand our planet's most essential resources. Great Lakes water volume. The Great Lakes contain 20% of the world's fresh water. This statistic appears in environmental reports, geography textbooks, and conservation campaigns across North America. It's become the standard measurement for explaining the region's water importance. But what happens when you examine the actual global freshwater distribution using current data? The 2025 hydrological studies reveal a more complex picture of worldwide water resources. Advanced satellite monitoring and ground-based measurement systems provide unprecedented accuracy in tracking global freshwater volumes. These comprehensive surveys include glacial ice, groundwater aquifers, rivers, lakes, and atmospheric moisture across all continents. The Great Lakes actually hold closer to 6% of the world's surface freshwater, not 20%. This lower percentage reflects better measurement techniques and recognition of previously uncounted freshwater sources. Massive aquifer systems beneath Africa and South America contain far more water than earlier estimates suggested. Antarctic ice sheets hold approximately 68% of global freshwater, while Greenland contains another 24%. These revised figures dramatically affect water security planning for both regional and global communities. The Great Lakes remain critically important for the 40 million people who depend on them, but understanding accurate distribution helps prioritize conservation efforts worldwide. Geographic misconceptions don't just affect how we understand water resources. They also shape our assumptions about where the world's most dramatic weather events actually occur. Global tornado distribution. Tornado activity spans the globe in ways that challenge common assumptions about where these destructive storms actually form. Ask most people where tornadoes occur, and they'll immediately say the American Midwest. This makes perfect sense given how much media coverage focuses on Tornado Alley, stretching from Texas to Nebraska. The United States reports over 1,200 tornadoes annually, creating the impression that these rotating storms are uniquely American phenomena. But what happens when you examine tornado activity across the entire globe? The 2025 meteorological data reveals tornado occurrences on every continent except Antarctica. These statistics show significant tornado activity in regions most people never associate with severe weather. Argentina experiences hundreds of tornadoes each year across its expansive plains. The Pampas region provides the same flat terrain and atmospheric conditions that make the American Great Plains so tornado-prone. Bangladesh reports dozens of deadly tornadoes annually, with some causing more casualties than American storms due to higher population density. Canada documents several hundred tornadoes each year, particularly in Ontario and the Prairie provinces. Australia's southeastern regions see regular tornado activity during their storm season. Even the United Kingdom experiences around 50 tornadoes annually, though most remain relatively weak. The geographical factors that create tornadoes, flat terrain, moisture availability, and colliding air masses, exist worldwide.